Hello, everyone. My name is Mike Korshinov, and I'm Team E for Service Provider Business Unit, or Provider Connectivity. It's our new name. Thanks for coming here today. And during this presentation, I want to talk about iOS XR programmability, what we are focusing on, how you can get it enabled in your networks, and how you can proceed with your automation journey. At first, let's take a look at some logistics. You can join the WebEx discussion, and I will monitor it for another week or so. So if you have any questions which you may not address during the presentation today, or some suggestions like feedback, please do join the chat and drop your questions over there. If we take a look at the agenda, we will start with adoption of iOS XR programmability, where we are right now, what's happening, what's our investment priorities in this area and technologies into which we are looking. Then we will talk about models and the type of models which we do support right now in iOS XR. After that, we will switch to GNMI and GNOI discussion. We will talk how you can use them in your day-to-day operations with iOS XR-based devices. Post that, we will switch to telemetry. We will touch base on the telemetry basics, talk about some new tips and tricks which you can use in telemetry, also cover some of the most popular use cases of the sensor paths which may be used in your network, and we'll wrap it up with conclusion. When we talk about iOS XR, typically it's a big platform of products, a big list of products, and we have the custom-based like silicon on ISR 9000. Plus, we have merchant silicon from Broadcom-based product family. This is Cisco NCS 5500, 5700, also NCS 500. And our most recent addition to portfolio is Cisco 8000. This is Silicon One-based product family. We had great sessions on it, and it's getting like more and more traction across our customer base. Plus, it covers also virtual form factors such as XRV 9000 or XRD. Our most recent addition, it's a containerized version of iOS XR, which you can just like spin up in Docker and run it on your laptop or on some servers. Also different form factors, iOS XR running on a third-party hardware or some older platforms such as NCS 6K, CRS, and like this type of stuff. Overall, we do deliver about three major releases per year. So we try to keep this cadence and deliver the new features with proper planning. And I will share some of the roadmap details with you regarding programmability. Our programmability story started in 2015. This is when the first development of programmability pillar was happened in iOS XR, and we introduced NCS 5500 back at the time in 2016, and we started to do young models to support them on our device, and it was our first implementation. We were just starting back in the time, and at the time we have few models. We were primarily native models, just like specific to iOS XR devices, and there are a lot of things which we addressed during the time. So the coverage of models grew, also the capabilities which you can do and how you can expose. Our approach with models changed as well. So it's evolutional process over here, and we are just doing iterative upgrades. Right now, if we take a look at the most recent iOS XR releases, it's more than 1,000 models available on the box. Tooling is much better, so you can just like scan through them, you can search through them, explore them visually, and I will touch base on some of the aspects which we are doing in that area. I would say we are moving to the early majority as of right now, because more and more customers of our products, they start to use some kind of automation, homegrown scripting, some solutions from vendors in order to automate networks using model-driven approach, and very slowly convergence happening from CLI. And from our side, we are also working on the model quality, so we have metrics to track of the backward incompatible models, and we want to keep the percentage really low. So with every new release, you would be confident with deploying the same stuff with young models on the box. So to summarize the overall situation right now, we are moving to the early majority, and this technology become more and more mature across across our vendors as well. So as automation solutions. When we talk about different aspects of life cycle, we need to distinguish few pieces. First of all, when you just get your device, you need to configure it. And for configuration, it's zero-touch provisioning or plug-and-play, whatever people call it. That's day zero operations. So you just get your device out of box, you rack it into your data center, connected it, and ZTP kicks in. So this is part of IO6i infrastructure. We are doing a lot of developments in this area, and most notable is Secure ZTP. To help address the security workflows in zero-touch provisioning, and there's a lot of discussions about that as well. But this is not part of this session today. Along with other components, but we're just to provide you an overview of what's happening around the infrastructure and operational system pieces. The control piece, we have service layer API and gRebuy, which is coming. It's basically giving you the access to RIB, MPLS, label switch to interfaces. And you can use API, Python-based Go or C++-based APIs to directly program your network. This is still in development from use case perspective, and this is primarily used by web customers. And last but not the least is the monitoring component. And within monitoring component, we have streaming telemetry. And I will talk about that a lot and how we can start to use it today if you haven't begin your journey yet. From technology perspective, I want to define two major pillars. It's netconf and gRPC. And when we talk about netconf, we are leveraging XML as the encoding. So XML a bit verbose, so it will take a lot of effort to process those messages, because if you want to read XML files, they typically big in form, but that's completely fine. And for people, especially with background in Java, that's pretty easy and pretty common thing to use before. So XML is the defined language for netconf, and there are a lot of standardization and developments happening in IETF for netconf specifically. So netconf using SSH as the transport underneath and TCP, and when you just get access to the young models available on the device. The other pillar is gRPC. And gRPC underneath is using JSON or Google protobufs. For JSON, that's very human-oriented, human-friendly format, which you can parse easily, which you can build your application. And this is tons of tutorials written how to consume your JSON file with Python and how you can use it. So this is super easy start for folks who are just want to have samples of what programmability looks like. And once you skill become more mature with it, you can switch to Google protobufs. Within Google protobufs, there are typically two different versions available, and one is compact Google protobuf, and another one is key value or self-describing. And with protobufs are super efficient. In terms of the amount of data you need to transfer, were the most effective along all defined encodings, but it comes with some operational challenges. For example, if you're using compact GPB, you need a proto file for each model to decode it, because once you have a protobuf, you will have just a binary, and you need some kind of a map to decode the legend, how to read this binary file. And this binary file would be proto specification for specific model per specific release. With key value, where you just have one proto file per everything, it's much easier and less overhead compared to compact GPB in terms of the utilization for resources, and it's a good kind of compromise between the JSON and the compact GPB. Also, gRPC is using HTTP, which brings us advantage of HTTP2, plus you have compression, so there are like some good amount of advantages in gRPC itself along with performance. We specifically decided not to invest in RESTconf because for service provider customers, typically we are less tied to REST apps. So we doing investment into two major areas, netconf and gRPC. You will not see RESTconf in our roadmap plans because we just see it as another way to consume boxes, and for service providers, those are like two primary ways to start your automation. With automation, we have different models to automate the network in terms of the software which you are bringing. So you can grab some solution from vendor, and in our case, it's Crossfork. You just install, you buy the licenses for Crossfork, you install the network controller, and then you run automation from vendor. It could be automation from Cisco, it could be automation from other vendors, but typically what will happen, that you will end up in some mix of the homegrown solutions and some mix of solutions from vendors. So you will not see the depiction on the left or in the middle. Typically, it would be some kind of solution in that area. And the beauty that most of those solutions were built with multi-vendor approach in mind. So when we will talk about telemetry and collection, both options which we will discuss, they would be like vendor neutral and would support not only Cisco IO6R devices, but other vendors as well. Okay. Let's talk a bit about models. Currently, we are doing two types of models. First one is native, and the second one is OpenConfig. Native models defined by us, and this is a fast vehicle to introduce new functionality. For example, if we are delivering new features in SRv6, and there are no standard body around that yet, so our way would be not for OpenConfig to adopt this approach with a SRv6 model. We will just push the native model right away. And our initial journey started with native models. So we have more than 1,000 of native models. And that's, they are not treated as a proprietary or just closed. We are fully transparent of publishing them, making sure we are doing a good amount of reports, and we are improving our tooling over there as well. So we have a good amount of native models, and we want to have the full parity between the CLI and the native models. With OpenConfig, the beauty of OpenConfig, that if you start to adopt model for interfaces, let's say, it will be the same for Nexus, for Junos, for XE, for XR, but then there could be some nuances and some details. Because OpenConfig wants to do the approach of integration with unification on the device level and not on automation level. And this hurts us a bit because we need to have common standard across all devices with different requirements, with different use cases and different build scenarios in order to adapt to the same standard. And this is a bit tough work to do. So for OpenConfig, we are doing a great effort to be there, but it will take some time to fully reach the coverage for OpenConfig. If we take a look from historical perspective, with 6.1.2, we've started with around 20 models for OpenConfig, and then we just gradually incrementing support with our most recent releases. So majority of the models for OpenConfig supported right now, but the question is, what about deviations and augmentations? So if we would take a look at what our vendors are doing and Cisco with it, there is not much deviations, not much augmentations around. Because if you do augment and introduce a new model or new leaf in OpenConfig, you just use the beauty of standardization behind. Because if one vendor doing one augmentation, another vendor doing another augmentation, you end up in a too custom situation where you need some kind of aggregation on top of OpenConfig to have reach some standard on top of it. So vendors typically do not do augmentations unless this is required, or some very specific augmentations maybe for optics and this type of very hardware specific details. With deviations, you need to closely monitor what's available and what's not, and we have nice tooling for that to do. I talked a lot about models, and there are multiple ways how to do exploration for the models. The first one, and the one I would recommend right now, it's Cisco Feature Navigator. So with Cisco Feature Navigator, you just go to the web page, and this page provided on the next slide, I believe. You will open this page, sign up with your Cisco account, or you can even use guest account without any registration. And you can review the model supported per specific platform, per specific release. So that's a very good visual way how you can explore native, unified, or OpenConfig models on our boxes. And the beauty of this approach, but you don't need any devices for it. Another one is to use GitHub repo. We publish every model supported on iOS XR to GitHub repository, and through this repository you can grab all the necessary models which are available to you. You can review them. There is no UI built in, so it's just a matter of your preference on your laptop. Maybe that's PyYang, maybe some other library, whatever is available. But GitHub is a way for us to deliver the Yang models which we support. So new release, next release 7.9.1 would be out. You would see the models published on GitHub around the same time, maybe with 1 or 2 days, like delta between releases and publishing on GitHub. There are two great programs available today. First is Yang Suite, and second one is Advanced NetConf Explorer. For Yang Suite, there was a session at Cisco Live before in DevNet area. You may saw it before. Basically, with Yang Suite, you can install it directly on your computer, on some server, and you can connect to the box. Once you connect to the box, you retrieve all the capabilities from that device. So you have different ways to connect. It's NetConf, it's SharePC, it's GNMI. So we do provide a lot of interfaces for communicating to device. So you're retrieving capabilities from the box, and you have exhaustive list of models which are supported on this device. Post that, let's say you are doing upgrade from one revision to another. You are grabbing second capabilities from the second box with slightly different release, and you can do diff comparisons. So I will not talk much about Yang Suite in details, but you can download. There's like tons of materials on develop.cisco.com, and it helps you to navigate and to visually go through models available on the iOS XR devices, and not only iOS XR. And it's a good way to explore models if you have routers available to you. ANX, or Advanced NetConf Explorer, that's open source tool. It's available on GitHub. It's only one Docker container, and it allows you to quickly get the capabilities from the box. So it's the same, almost the same functionality with Yang Suite, but it's just a bit lighter and slightly lesser functionality. For example, if I need to find specific telemetry sensor path, I would prefer using ANX. But if I need more extensive workflow for working with models, I would use Young Suite. But it's just a matter of preference, and once you have a look at both, you can pick whatever works for you. And if you want details for specific deviations when they would be supported, or some more details, you can reach out to account teams, to me, and then we'll provide those details when specific deviations would be addressed. Because from models coverage, we are doing pretty good and a lot of models supported. But for OpenConfig, some specific leaves you may be looking for right now, maybe not. We can address direct and privately for the types of the roadmap, and when currently specific deviation which you're looking for would be addressed. This is how Cisco Feature Navigator looks like. You don't need to have registration. You can just continue as a guest on the site. And this tool was introduced in October last year, so it's pretty new. We will do multiple revisions of this tooling with more and more functionality added to it. And if we take a look what's available to us, so once you open this link, you will go to Young Data Models. When you pick your product, and within product, you will pick iOS XR release. And now you have native models, you have unified models, and you have OpenConfig models. What's good about the tool? It will tell you which type of models supported. So we can see that we have 160 native models available on the box, 230 operational models available. Plus, you will have information about the model itself. That's, I believe, how many nodes you will have in this specific model. This is obsoleted models. Those are deprecated leaves and not supported leaves, and 50 leaves in total. And you will see this information per specific model, so it's a very good way to explore the functionality of the box without actually getting to the box, because this is built from our code base. We just traverse the code base. We just taking a look at what's available per specific platform, and then just dumping it in a database after some conversion and making it available for our customers. In the end, we have multiple updates planned for this tool, and relatively soon we want to push all the leaves supported for on-change telemetry notification. So that would be a good way to explore what you can consume on a specific cadence, or just for on-change or event-driven telemetry. Young model documentation. This is our previous way to do things. We still keep doing that, and you can just go to this link and explore the GitHub repo with all details over there. We are doing capabilities because it's more than 1,000 models right now, so the view on the web page would be a bit trimmed, but that's fine. When you just clone all the repo and review it on your workstation, you can see all details. And what's the beauty about it? You can just use your preferred tooling, but and you don't need any device to explore those models. So this option is still available. We'll keep pushing for it. It's an automated process for us, and we're just doing our due diligence to publish all the latest models available. Plus, what's available within the folder is backward incompatibility report, and you can run the script to do incompatibility between multiple reports. You will see what's the changes, and the script will just do the dump for you if you're planning to do the migration. So it's one of the important stuff over there. Again, with models, I talked a bit about native and unified models and OpenConfig one, and I will talk more about what's happening with unified and why introduced slightly different representation for it. With OpenConfig models, what's happening? We are doing abstraction on the device level. So this is device level where we just put OpenConfig model, and either you are using iOS XR or Junos or Nexus device, there will be OpenConfig module, which directly located here. But let's say not all devices created equal, some different functionality supported, some designs also different. So what's happening, it's a bit hard to do the consumption for it. Let's say we are exposing CPU for 1 minute and for 5 minutes as a parameter for telemetry. And then in OpenConfig, it would be 3 minutes. So we need to do a work to do the proper mapping to expose the value for 3 minutes. So it's not available out of the box, but in theory, it's good to have 3 minutes utilization for all CPUs from different vendors. Of course, if it's fully supported, if there is no deviation, and if revision for the model is the same. Because revisions are also important, and you can see which type of revisions like supported in the feature navigator as well, because we publish this information on the tool within UI, so same page. As I mentioned, we have native models, and initially we started with non-unified models. This project was begins in 2015, and with non-unified models, there was different abstraction for YANG and CLI. So it took us a while to adapt to the new proper structure for unified, because we were learning as well, just like how to make it properly. And when we have unified models, we are doing full parity for the coverage. So for every CLI, there would be unified model, so you will not see any discrepancies between CLI capabilities and YANG model capabilities. So eventually we will sunset non-unified models, and this is a journey which we are doing for a few years as of now. And with unified models, we just have only one config definition, and then it's just mapped either to YANG config or to CLI config. And for non-unified, it was just like two different mappings, config definition and config schema. So this is our internal plumbing to make things better and more user-friendly in general. And if you take a look at unified native model, we have the example for BGP. The unified model, it will follow the CLI structure pretty nicely, so it's easier to consume. With non-unified, we were a bit more verbose in this representation, but now we just trimmed down the model to have XML tags built more shorter, I would say, and to have less verbose outputs for models. So the model is more user-friendly right now on its own. This is about the models, and I want to introduce you to some new XR features which are happening around OS and how you can benefit from them in your deployment scenarios. Recently, we introduced XR config scripts, so you are doing some interaction with a device, no matter which type of interaction is happening. And with those interactions, you can enable some of the Python scripts on the box directly. They typically tied to the configuration or operational scenarios. The first type of script is exec script. So exec script, it's the script which you will invoke from the device itself, and then you can do some manipulation with your device. You can export some data, or you can just do some analysis or some checkings for the box. And typically, this is manually invoked process on the box. Another one is the config script. So if exec script is invoked manually initiated by user, the config script will do the work on the at the moment of the device configuration. So it can check for some boundary conditions and if user configuration is properly applied. For example, you want to have ACL available to you for each or for some individual interfaces, and with configuration script, you may check that your desired configuration will still include ACLs for those interfaces. And if not, config script will tell you, oh, buddy, you're doing something wrong. You need to keep ACLs over here. So this is a way to prevent your device from going into the incorrect configuration and helps you to just like introduce more stricter guidelines about device config. Embedded event manager scripts, it's another one. So this is various internal mechanism which allows you to analyze syslogs, some internal temperatures, and like some parameters on the box itself. And this is like more sophisticated one. So we have documentation and use cases published on the link below, if you see it in the bottom right corner. So if you're willing to learn more, how you can work with timers like tracebacks and this type of mechanism, you can check for more examples on the page. And last but not least, the process script. The process script on its own, it's more permanent thing living on the box, and it's just additional process on iOS XR, which takes care of specific functionality for the box. So you want some data to be constantly monitored, or you want to check device parameter or some host stats, you can do it with some process script if it fits within your tooling ecosystem. This was introduced in 7.3.2. Documentation is published. Also, some examples are on GitHub. If you're willing to use it, you're more than welcome to. Some other tooling which we worked around programmability to make the consumption easier for our end users, such as equivalency tool. You can use Young Describe, and then it will be operational for some of the commands available to you on an iOS XR device. So let's take a look on the first example. Young Describe, operational, and then show interfaces brief. Internal logic will try to find the corresponding model, which will show the proper model in Young format. So you just start with show interface brief. You know the CLI, but you don't know the model for it. And that trick will help you to find the correct model for telemetry. When you go into feature navigator, you search for this model, and then you can navigate within the model how you can consume it and what's interesting clips for you in this particular model. So it's just one of the tooling available to make consumption for the models easier. Another one is you getting traditional configuration. Let's say I want to check my ISIS configuration on the router, and instead of CLI, I want to start to use model. How would I do that? You need unified model for configuration, but you don't know where to start. With that tooling, you can do show run router ISIS, just your typical CLI command, and then you can expose it in unified form factor, so in Young model. And when you just like have your data, this is the model, iOS XR ISIS configuration, your instance, it's running, network, and then address families. So you have the full configuration. I just like trimmed the output because it's a bit longer, but you got the idea of it. You can just start adopting the usage of models by tooling available to you on the box. So it will be iterative migration, and you can migrate it step by step and get your full configuration in a model form factor. It's also compatible with OpenConfig, so you're doing XML unified models or OpenConfig, whatever works for you. Oh, too far. Another one is MDT exec, and basically we've run MDT exec. It's available on all iOS XR devices for a while, but not a lot of people are still using it. It creates a virtual subscription on the box directly. So you go into iOS XR CLI, you run command run MDT_exec -s, and then you specify the sensor path. This sensor path, you can explore it from Feature Navigator or other tooling from your arsenal, and the output would be right here. So you can just grab this JSON file, process it in some tooling, in some Python scripts or whatever, and can use it for future automation or integration. So you don't need to have whole telemetry stack for it, because this you just drop to CLI, use it, check the output, work with this output, adjust it to the structure you need, and then consume it by some of your tooling or automation if you're doing homegrown. So this is also a nice utility which is available out of box, and it's available for a while. Now I want to briefly talk about roadmap and what we are focused on. We are working on programmability from 2015. Technology is getting more mature and mature. And as I mentioned, we don't want to support RESTconf because right now we are looking into primarily netconf and gRPC related utilities. We typically divide the effort from engineering side into three categories. First is model enhancement, just keeping models up to date with more recent revisions, how we are doing the ecosystem and consumption around models easier. And what's happening on that front, it's just like unified models was a big help to us to create a more concise and leaner way to configure a device. Another one is OpenConfig uprefs, because OpenConfig community, it's moving forward and it's moving fast. So we need to be on par with the community and to keep pushing latest revision for the box. So we're closely monitoring what's happened within OpenConfig and making sure that most critical changes are addressed and supported within iOS XR devices. So you would see a lot of uprefs for different models available within config. And then infrastructure enhancement. This is, for example, 741 CLI to YANG mapping tool, which I just showed to you. Telemetry regex filtering is another good example. So you don't want, for example, to stream information for all interfaces, and you want to focus only on 100 gig interface. So you can put a small regex expression within the sensor path, and then you can export only data for those like 100 gig interfaces, and you will not transmit data for all interfaces which you don't want to look. So it just provides you to export more granular data from the box itself. Model-driven telemetry, a lot of enhancement on gRPC and GNMI, and we are doing more and more on the netconf stuff as well. So accounting, logging improvements, more tooling available to you, and this is already all public. And what's our priorities for the next year? We keep hardening the infrastructure. We are doing more protos for GNI, and I'm going to talk about it. And also we are just doing improvements on the get and set functionality for GNMI as well. Plus, we finally reach below 5% of network compatibility. So backward compatibility for models. So we, when you're doing the upgrade from one release to another, you have more and more stable models over time. Let's talk a bit about GNMI, and this is another way to consume your device data. And the beauty of GNMI, that it's just a set of RPCs available to you with rich tooling around it. So the main goal to provide unified encoding and with transport protocols. And I will provide the example how it works and what's happening in reality over there. Within GNMI, there are only 4 RPCs available to you. The first is capability. And capability is kind of a service utility which is just not used to manipulate the box or to update some of the operational or do some action on the device. The capability just talks to you about what device is capable of, which type of GNMI specification is supported, what's available to you, which type of encodings, and what models it's capable of. So that's pretty straightforward, and typically it's used by some automation suite in order to understand the box capabilities first, in order to adjust the operations. For example, are you doing JSON IETF or proto encoding with this box? You need to first check capabilities for the device and then just work with box using within provided capabilities. The next one is more interesting, is set. And with set, you can configure the device itself. So it's just like a write operation for your box. You just like telling, oh, I want to do those type of operations on the box. You use the set RPC, and your device config would be updated. If you have a set, you need a get as well, because you want to know what's happening on with get operation, and you can retrieve specific models, specific like CLIs from the box. So it helps you to retrieve the device current state, and it helps you to just like do the full manipulation for the box. And last but not the least is subscribe. And subscribe is used, it's primarily for telemetry. With subscribe, you can do different type of parameters, and what's important for us, it's the type of mode for subscribe. It's stream once or all. With those operations, you either doing periodic streaming for the information which you subscribe to, or maybe you just requested it for once, or maybe you are just doing the polling mechanism. So because if you just like stream for on change information, it would be the necessary information for you to consume, and you don't want the rest of information to be available to you. And this is the primary idea behind the cadence-based telemetry, where you just stream everything 30 seconds. You just like push all the data 30 seconds, versus you are streaming updates. When update is happening, you are good to consume it. The rest of the data you are not interested for. So same mechanism available within GNMI. And with GNMI, in order to check the subscription on the box, you can use the all standard commands like show telemetry model-driven subscription, and you will see that it will be available to you on the box. This is a sensor group to which it's subscribed, and the status of them is resolved. That means that you are in a good shape over here. This is like more detailed view for the particular subscription, so you can just have idea of what's happening per each individual sensor path, and I just like trimmed the output, so you just like have some kind of a snippet. With GNMI, there is one more advantage which is worth to mention. There is no configuration needed on the box. So what you are doing, you just enable gRPC when your whole configuration for telemetry is empty, and GNMI will dial in to the device. Will tell the box that, oh, I'm looking for health parameters, or for optical, or for inventory out of the box. And it will tell the box to subscribe to those particular sensor paths, so no predefined configuration required on the router itself. So this logic is on the controller. Of course, you can use with gRPC, you can use the standard way by defining the whole config on the box, but with GNMI, you don't need to. Why GNMI is important and why it's happened on its own? Because gRPC is kind of proprietary implementation. There was no guidance how for each vendor to implement gRPC. So each vendor defined their own way of dealing with gRPC and typical RPCs available. If you would take a look at RPCs available for Cisco IO6R devices, this is like get config, merge config, delete config, replace, yada, yada, yada. For Juniper devices, they would be slightly different set of RPCs. But with GNMI, you are doing definition for standard RPCs on the box. So no matter which type of box you are using, Cisco IO6R or Juniper devices, it would be still the same RPCs available to you. So that's why it's important, and that's why we added the support for it. Because we want some unification on RPC level, so you wouldn't bother which type of internal mechanism implementation underneath the box. So with GNMI, you have this unified encoding. And there are plenty of clients available to you right now. For example, you can use PyGNMI, you can use official client, OpenConfig GNMI, you can use GNMI-C, and those clients, they just implementation in different languages. We will have more information published on the examples how to deal with iOS XR, but basically it's you grab any documentation for client, and it will be the same type of commands to configure or to retrieve device capabilities, to read device state, and this type of operation. So in general, there are not much differences between vendor boxes which are used by GNMI clients. So just pick client which you prefer, or if you want, you can build your own, because if you follow this specification and this definition for GNMI, it will work with any vendor, because we are supporting GNMI specification from our side, and by doing this, we are complying with the standard. So any open config GNMI based client will work with our devices and with devices from our vendors. Let's talk about different component. It's called GNOI. And if GNMI is just the interface for interact with device, it doesn't cover the actions. And with GNOI, you can have a different type of operations on your box. For example, you can have ping, or you can do certificate rotations, or you can manipulate, do some device actions. So those RPCs and GNOI, again, they would be standard across our vendors as well, and they just provide a unified way for ops on the box. If we take a look at the roadmap, this is what's available right now. So from 7.0 up to current releases, you can see that we started with a few examples for system management. So you can reboot the device. You can work with specific packages. In order to work with specific packages, you need to get them. So you have all your file RPCs available to you, also some retrieve some statistics. And we keep adding new RPCs to the box in order to provide more and more operations available through GNOI. So again, GNOI and GNMI, they based on gRPC. And if gRPC implementation is proprietary, this would work across different devices, across different vendors. Again, you need to check if specific RPC is supported for specific release and specific vendor, but the idea, if it's supported, it will be available across whole landscape of router ecosystem. This is more recent, what we are adding, and we keep doing more and more stuff. So currently we are doing more on MPLS, and a bunch of RPCs going to be added in future. So stay tuned for updates in this area. Okay, now let's talk a bit about telemetry. And telemetry is a big and massive change compared to SNMP, because with telemetry we have a massive performance increase. So it will not load your box the same way as SNMP does, and you can push more data out of the box, more formats available to you. The mechanism is more efficient because it's first of all designed with scratch, designed with scalability in mind. The encodings also just doesn't matter for your performance. It only matters for transferring mechanism. So it will not load the CPU that much. And again, routers are not servers, so we're trying to limit the CPU, the memory available on the boxes we ship to have some logical limitations for those resources. So you need to use device capabilities with those limitations in mind. And with telemetry, you can do it much more confidently compared to SNMP. Configuration for telemetry is super easy. First, you just tell the definition of where you want to push your data, what's the server, and how you want to do your data search. For example, I'm doing JSON or gRPC with no TLS, with TLS, And you just define the configuration for where and how. And then you need to export what type of data I want to export. So you define sensor group. Let's say sensor group would be for BGP, for OSPF, for ISIS, for optical. This is what you're pushing out of the box. And last but not the least is the how often. And you just tell the subscription to particular group, to particular destination, and the sample interval. If you set sample interval to 0, it will be event-driven telemetry, but it's not supported across all the models as of now. And relatively soon, we'll publish this information via feature navigator as well. So this information would be publicly available. Currently, we do support only a few models for event-based telemetry, but our adoption is growing over there. In terms of encoding, I briefly touched based on different options. JSON is the most human-friendly way to transfer this data. Any small application, you will have thousands of examples in DevNet how to parse JSON, how to consume it. It's a very good start with telemetry in order to retrieve your data and just play with it, because it's human-friendly, it's very friendly for developers. You can see the data, it's native to Python, so there's no problems in consuming JSON data. But it's not efficient on the wire. And if you're deploying it for production, you want to have it efficiently utilize your resources. And we talked about a few tricks how you can increase this efficiency. But first of all, you need to switch to Google Protobuf. And again, within Google Protobufs, we have two types of encodings. And with compact, everything would be binary. So this file would be not readable at all. It will be just one binary. So you will need one proto per model. And this is operational challenge over here. Because one proto per model, it means if you run it for one vendor per particular release, you may be exposing 30 models or 50 models. You need 50 proto files. When you're adding new release, you need to double that amount. And if you're using multiple vendors, you just you keep counting your proto files. The delivery mechanism should be established. So it's not that easy. That's why our recommendation would be to go with key value with Google Protobuf, and then this string would be just used by keys, and the values would be binary. So you need only one proto file for it, and this is a significant improvement, and you still have performance advantage of Google Protobufs. So it's a good middle ground for the encoding over here, which will give you pretty good results in terms of your wire utilization. Now let's talk about how you can initiate the connectivity between the box and the collector. There are two ways to do it. You either doing dial out or dial in. And with dial out, you just initiate the collector from the box. So the first SYN request is sent to collector, you get SYN acknowledgement, and then another acknowledgement sent, and your handshake established. This is the way where you initiate everything from the box, and it's supported for TCP, gRPC, and UDP. Again, from the mechanism for transferring the telemetry data, my recommendation would be to use gRPC. In case if it's not working for you, go with TCP. And UDP, we just got a few customers who were interested in this type of mechanism to sending message. So we added support for that, but TCP or gRPC is the best way to do it. When we switching to dial-in, the methods limited over there, and you can do either gRPC or GNMI. And with gRPC, what you need to do, you just expose port on the box. You are telling, oh, I want gRPC agent to listen on 57400. And then from the collector side, you will tell, okay, I want this is router IP, this is router domain name, and this port I want to use. And the collector will dial into the router and will initiate the collection. And with GNMI, it was a native approach from the scratch, because GNMI thinks about dial-in as a primary mechanism, and the beauty, as you saw configuration which required on the box in order to enable telemetry, there is no need for such configuration to be available on the router. So what's happening with GNMI, you just like dial in, and then you tell the router to subscribe to specific sensor paths, and that's it. Based on customer request, we actually added GNMI dial out as an option, but it's not available for every platform as of right now. We are planning to expand that, but if you're using it out, if you want to use that right now, probably this is the safest combination to go. Dial out could be interesting for you if you have some firewalls in between and you do not have a direct connection from the collector to the router. So let's say your collector somewhere in the cloud and you don't want this collector to just go into your private network, but if there's some firewall or some limitations, it could be different departments which are responsible for it. So you may still want to do initiation from the router to go to this public cloud and then to start streaming data. So as an option, dial out for GNMI exists over there, but again, basically try to pick the preferred way for you based on available scenarios right now. Between TCP and gRPC, I would recommend to use gRPC because of the advantages it offers to you. There is no encryption within TCP available, so you can use this as a part of gRPC advantage if you care about which data is streamed out of the box. You can enable two options, and by default, when you configure gRPC on the device, TLS would be enabled. So what you need to do if you want to disable it, you just go into CLI, gRPC, no-TLS command, and you commit it. And post that, you will have the capability to do the unsecure connectivity to the box, so without TLS. But again, you will dump the output, and you will see all the credentials available in a plain text, which is not good, and especially for production networks, it's not recommended. So TLS is the preferred way to do it, and you can put certificates on the router and just to use the passwordless authentication, and then you have the full-blown encryption capability available to you on the box. So that's a good addition when you're considering what to do and how to properly stream telemetry. We got a lot of questions about, okay, where should I deploy collector? How frequently should I export data out of the box? And there is no silver bullet or only one scenario, because everyone needs is unique and different. So I would recommend to start slow with telemetry, see how much data you are exporting, and then just keep it growing and export more and more, and monitor how much data you would see. Again, routers would be still limited in resources, so there are a few tricks how to limit the exported amount of data available on the box. In general, the most critical parameters for scaling telemetry is the cadence. So we do recommend the cadence to be somewhere from 30 seconds up to 10-15 minutes. It would be the most optimal parameter, because you have also question with the data. You get a lot of data from the routers. You need to store it. You need to aggregate it. You need to analyze that. Do you really want to have sub-seconds for your data? Maybe the answer is no. And telemetry is used for more for detecting the problems and kind of predicting them, but with some analysis behind. It's not there to just like detect problem in sub-second, because this is not how it's designed. And what's important, you set the cadence, and then you need to define your devices to collector ratio. So probably around 30 routers per one collector with typical modern server configuration would be sufficient. But again, SSDs, they do have limited lifespan. So if you just like pushing data to them very frequently, you may end up with killing SSDs in a few years. So there are like multiple things to be aware of and take in consideration when you're building your collector base. Good thing to have high availability for your collectors and have multiple collectors deployed within your network. So that's important aspect for it. And again, we tested telemetry with a lot of data. So what we did in terms of performance, we just put a very big chassis, loaded it with 100 gig line cards, and conducted the testing on it, and it was working fine and smoothly. Just like don't push it too much in terms of just like sending information about all paths in RIB every every 2 seconds or something like that, and you should be fine. We also tested telemetry to do like 100K interfaces on ISR 9000. So from performance perspective, we are confident in streaming telemetry mechanism. When we introduced GNMI, it was not on par with telemetry performance, but we fixed it as well with recent releases. So in general, we are pretty confident in terms of where we are with performance for telemetry, and we are just like telling our customers to use it more and more because we are not investing any more resources in SNMP. And this is the time to migrate from SNMP to streaming telemetry. You have better quality and better results. You have a question?
Or we can also transfer the output of the command to the controller and then process it. So where I'm doing the Python scripts to collect some outputs from the show outputs from the protocols like EVPN or other technologies, can we do it same with the telemetry?
Yeah, you have. We need to distinguish. First of all, we need to distinguish two things over here. First is configuration, and then operational data. And all operational data you can expose through telemetry. So you are doing show information about ISIS neighbors. You can explore this from telemetry. And again, if you want some kind of combination of telemetry plus some show commands from the box, you can use, for example, GNMI get RPC and then retrieve this data. So you can use combination for both scripting and telemetry over here.
So this is better than Python automation using telemetry, so that.
No, it's good in both ways, and you could use Python clients to do it. So I'm happy to discuss the design with you and what you can do like with next steps over here. So let's chat after presentation.
Thanks.
Okay, sounds good. So telemetry offers you a lot of data available from your operational models. You saw Feature Navigator to go and traverse each model available to you, and every command, every information bit which you can retrieve from CLI, it should be there from telemetry as well. And if you do not see some counter available in CLI and not available through telemetry, it's a bug from our side, and we will work to fix it. For migration, we published SNMP guide, how you can start with it. We will publish more information about some gathered and validated MIBs to telemetry sensors available to you right now. So if you haven't started this process for migration, it's a good time to do it. I was talking about TCP versus gRPC and some of more features and new enhancements of IOSXR. It's, for example, gRPC compression. With gRPC compression, it's not required for GNMI clients, but for configuration under gRPC, you need to use the keyword gzip. And when, if you compare the data with compression or without compression, you will see the tremendous performance increase. And in red, you have you have information with how much faster it like, transferred with compression over there. So again, when you're using gRPC, you have few benefits of encryption, you have few benefits of the processing time, and benefits of HTTP available to you. Because resources are limited, we are trying to do other types of optimization, and from 7.2.1, we can do leaf level filtering. So you don't need to stream the whole container for BGP, for example. You can do the streaming only for particular leaves. And this will allow you to save a lot of data from the box, and just not stream unnecessary information which you are not looking for. For example, byte sent is the only parameter you are looking for, and there are 15 more, you don't care. So why should you stream it, and why should you use bandwidth for it? So in this scenario, you just avoiding streaming too much information which you doesn't need, and it helps you to offload the network like, consumed by telemetry. So those are like leaf filtering, regex filtering, and a small nice feature which just makes consumption of telemetry a bit easier. Again, I mentioned that with GNMI, you are doing only dial-in, but if you want to take advantage of GNMI dial-out, you can do this kind of tunnel. So this is a relatively new feature. It's supported on NCS 5700 right now. We are increasing support for it to other product families in the future releases. And basically, you can do the tunnel from the box. So you will need some configuration available to you. And then you specify the tunnel destination and port. So by doing this, you imitating the dial out from the box directly, and you are not limited to dial in for GNMI only. Okay, from telemetry perspective, you have different options available to you from the collector stack. We had pipeline for a long time, and we are sunsetting pipeline in favor of Telegraph. Telegraph is the product developed by InfluxDB, but it's a very lightweight agent, and it helps you to get the information from the box with specific input plugin. I will talk a bit more about Telegraph just in a bit. Once your data exported from Telegraph, you have multiple options, because Telegraph is super powerful with tons of output and input plugins. And you can use it in any preferable combination. For example, with InfluxDB would be the most traditional time series database, which we saw a lot of examples. You will go to World of Solutions at Cisco Live, you will see a lot of instances of Influx and Grafana running on premises. Prometheus is another one. So again, Telegraph is pretty powerful in terms of the plugins and output exporters to which it can stream data. So you have plenty of options over here. Or maybe you want to do your Kafka bus and just like have one data lake to which you just like push all your data exported from device and just have external agents processing your information and just like use it for further analysis. So InfluxDB is the most easiest and the most common scenario from open source perspective over here, and I would recommend to get you started. We have plenty of tutorials and materials available how to configure all that stuff, and initially you don't need even like paid version for Influx, but when you're growing and moving to production, it's good to have a commercial support from the company you are referring to, because you will need scaling, you will need clustering for those instances. So, and those features typically provided with payments for products. Another one is visualization, and with visualization, Grafana is the most common product. You can build your dashboard over there. There are like a bunch of dashboards already published for you, and we are doing a lot of publications on xrdocs.io/telemetry. This is our website for publishing materials for telemetry specifically. And with Grafana, we recently added a new product on call. So you can have all visualization for your telemetry data. You just build your dashboards, you just customize it in a very nice and very granular way how you want to see your operational data. And when you are using on-call to do incident management. And with incident management, you just have network operator responsible for some part of your network to be available to receive and to troubleshoot network when it's needed, and have a sophisticated pipeline for escalation of those incidents which may happen in the network. This is typical stack which you can start very quickly with, but from the collector perspective, again, we have Telegraph and Crosswalk Data Gateway. Those are two main recommendations from our side right now, but we mostly just push the data out of the box, and it's up to you how you want to consume this box. As I mentioned, within Telegraph, there's a bunch of plugins. There are plugins not only for Cisco, but for other vendors. And most usable plugins for consuming devices from iOS XR, it would be Cisco Telemetry MDT, which you have configuration on the right side. So you just this is telegraph.conf. This is the standard way to configure Telegraph. And when you start with transport, so transport you use either TCP or gRPC. If you're doing dial-in, you can use this service address for the box. So it will be just the port and the port for router to communicate to, or if you want to dial into the box in case of gRPC, you will need to specify the IP address as well. Then some parameters about the message size, TLS if you want it to be available to you, and some other parameters for configuration. But basically, this is the first few strings which just needed for configuration. And if you have questions about Telegraph, we have pretty good experience. So with it, just feel free to ask them. This is for Cisco Telemetry MDT plugin. There is plugin for GNMI. Initially, Cisco dropped a plugin to Telegraph to have GNMI support. But later, Telegraph, they just developed their own plugin for GNMI, and now we just it's officially supported and lifecycle for it maintained by Telegraph. So now there's official plugin for GNMI, and you can use it for all GNMI-related subscriptions. There is also plugin for SNMP because it's still there. You still have networks with SNMP enabled, so there's you want it to be available for consumption, and Telegraph offers plenty of ways how to use it. The offer from Cisco from collector side is the Crosswalk Data Gateway, and with CDG, or the acronym for it, you can consume the data from multiple vendors, from multiple devices, and this is your collector for all your needs, designed and built by Cisco. So it's targeted for mass-scale deployments. It has all we needed, scaling parameters built in. So it could be your central way for consuming and ingesting all the data available to you on the box. Also, CGG, it's a part of the Crosswalk solution automation, and probably you can run some Crosswalk network controller on top of it, and it will just feed your CNC and Crosswalk setup for the future network. There are different options available for deployments over here, from smaller to largest one, and we have dedicated session for Crosswalk automation suite at Cisco Live as well. We are probably over by now, because this is the last session for Cisco Live, but you can watch recordings for them, and we have pretty good representation from Crosswalk team who did all great sessions on their products. I provided sensor paths over here just for reference with all necessary information. So where you can start with interfaces, uptime info for VBox, some information about memory, CPU, fans, power, and most common processes, information about RIB, BGP. There is much more, but if you just willing to start with telemetry right now and just don't know what use cases to pick, this is probably a good reference slide for you to take a look at and get started with. In terms of use cases, we are offering some guides, some materials, some documentation on how you can migrate from SNMP to model-driven telemetry available to you. And this is a process. This is a lengthy process, but telemetry is mature. You have better output, less load on the device. So start to use it right now. And there's plenty of use cases which you can do. For example, after ticketing mechanisms, if something going wrong, for example, your port went down or some threshold exceeded for some system resource utilization, you can use telemetry and external system to generate tickets for you, and engineers would be assigned to those tickets and close those tickets once the issue is remediated. Another one is BNG automatic IP address allocation for clients. You can monitor it with streaming telemetry, and you have we have pretty nice dashboards available for it. Load capacity planning, so you can use traditional methods or you can use machine learning because you have all the data available to you. So you can either build just visualization or you can analyze the raw data for it. So different scenarios available. And again, if you're grabbing some solution off the shelf from vendor, you will have those use cases and KPI built in. And if you're doing a homegrown solution, you just observing what you need right now and building a custom to those needs, because the device is capable to export you this data. You just need to consume it. One good use case for optical, for example, where you can monitor all transmit levels for information, you can monitor the signal, and you can predict when a particular transceiver will start to degrade, because you will clearly see it and data, and this degradation could be nicely observed through dashboards. As a part of the innovation of improvements which we are doing on our devices, we also have some AI-driven telemetry. There's more use cases to explore over there, because we can start to expose more data from the box and do the correlation between events. So if there's a spike in traffic or some interface is down, we can do internal analysis, and there's already like a model available on the box, and we can push related info to our collector with necessary information for troubleshooting. So there's different things which we are doing around telemetry, not only infrastructure enhancement, but also thinking about smart ways to consume our data. And by conclusion, I want to summarize the technologies which we discussed today and share some information about roadmap. We have a big list of platforms. So because telemetry is mature, if you're using various standard technologies such as gRPC and key value GPBs, protobufs, you're probably in a very good shape. If you have some legacy platforms, you need to check what you want to expose. But again, we are making our information about the models more and more available, and Feature Navigator is the way to consume it. We added GNMI with 6.5 when we just bumped the revision for GNMI, so we are progressing towards that direction. And overall, if we take a look around GNMI netconf support for other devices as well, you will see that all operation system from Cisco supported from some release, and the actual so it's supported, and the question would be if some specific functionality is required to you for netconf or for gRPC, is where it will require a second level of investigation over here. If we summarize the whole picture, so we have young models available to us. And those young models, they could be either OpenConfig, which are standard and would be applicable not only to our devices, but to other boxes as well. Or we can use native, unified, or non-unified models in order to get faster speed and faster delivery for new features available on the box to you right now. Another one is GNMI. With GNMI, you can retrieve capabilities, do get and set for the box to read and write information to it, and subscribe to telemetry. So this is unified way. GNOI is another set of RPCs which helps you to do the action on the box, such as like ping or like trace route or get the package or get the file or clear label counters. So those are mostly action activities available to you. So you don't manipulate the state of the box. You just like doing some operation on the box. And gRebuy, we added support to it. Only a few RPCs supported over there. But when we introduced our service-layer API, there was no unified protocol or mechanism across vendors and no public definition for it. So service-layer API was available very early from iOS XR6 and moving on. And now we have kind of unified interface for routing information, and this is gRebuy. So again, we added support for few verticals over there, but more things to do. And in terms of the surveys, please complete the surveys. It's the last session for today and for the show. I hope you had a great time during the show, and we have 5 minutes for questions. So I can address them right now, or we can catch up later today, or feel free to drop them in WebEx. Thanks.